Hello everyone. Um, we'll be looking at statistics and probability distribution in this lecture. And this lecture has been divided into two parts. As we saw at the beginning of this subject, the aims of any production engineering industry include productivity. So there's a product that you're supplying the market, and then profitability. And finally, we said you have sustainability, meaning the industry should be able to keep itself running for over a long period of time. In order for an industry to sustain itself, risks associated with production and the quality of the products are important. Hence, in the context of this subject, statistics and probability distribution are used for quality and risk assessment. There are different forms or different measurements of statistics and probability distribution. The very first set are called measures of central tendency. And they are called thus because they represent the center point, or they are typical representation of a data set. So you have mean, median, and mode. So any of these measurements will be a typical representation of the data set. So that's the third thing they also imply is they are used to identify the location of a data within a data set. The very first measurement is the mean, which is calculated by summing all the data or the values present in the data set, and then you divide them by the number of values present in the data set. So that's how you calculate that. The second measurement is the median. But for I want you to take note for this measurement, before you go ahead, the first thing you need to do is you need to rearrange the data set. And the arrangement can either be in ascending order or descending order. So it can either be in ascending or descending order. The most important thing is it should be in an ordered array. So after doing that, the next thing is then identify the midpoint. So the median represents the midpoint of the data set. The other thing your median does is it divides the data set in half. So you have two equal parts. So if we are to look at this first data set we have here, you see that this data set, the number of values in the data set is odd. So based on that, it's easier to identify the midpoint. So the midpoint here is 5. On the other hand, for this other set of data, you see that the number of data set is even. So what you do is, so if we are to count from the bottom, we have 2 values here, 2 values here, and then we are left with 30 and 40. So in order to calculate the median, we sum the 2, we have 70, and we divide it by 2. So that gives us the median. The last measure of central tendency is what we call the mode. And mode is used to describe the most common data within the data set. So it's used to measure frequency. So if we are to look at example 34, you see 1 occurs 3 times. 1, 2, 3. So 1 is the mode. But in example 35, you see that 5 and 10 both occur 3 times. So we'll say that this data set is bimodal because there are 2 modes there. The next measurement that we consider in statistics and probability are what are called measures of non-central tendency. Unlike the previous set of measurements that look at the location of a data set, these particular measurements look at the position of a data within the data set. But before you do that, what you need to do with the data set is you need to arrange the data set from the smallest to the largest. You need to arrange the data set from the smallest to the largest. The next thing you do is you divide the data set into equal groups or into equal parts. So for example, let's start with the simplest one, which is quartiles. Imagine cutting a chocolate bar into 4 equal parts. How many cuts will you have? How many? So you'll have 3, of course. So if you have 3, so we have 3. So the 3, so we have 4 parts, but so take note, we have 4 parts, 2, 3, 4. 4 equal parts, but we have 3 cuts. So these 3 cuts are what we call the quartiles. So that means when we have 4 equal parts, we have 3 quartiles. When we have 4 equal parts, we have 3 quartiles. And in order to calculate them, the first thing we do is, remember what we said, you need to arrange your data set from the smallest to the largest. So that's what we've done. So this was the original data set and it's been arranged here. Then you use this formula. So our n is the number of values present in the data set. So we have 0.25 n plus 1. So we have that for our Q1. We have for our Q1, and then we have this for our Q3. And then it should go without mention that our Q2 will then be 0.5. Will then be 0.5 n plus 1. 0.5 n plus 1. So if we are to calculate that, you see that it's same as the value you get there is same as the median. So the value you get there, it will be the same as the median. Take note of that. And then we have decile. So deciles meaning 10 equal parts. So 10 equal parts. So as we saw for quartiles, so for when you're looking at quartiles, 4 equal parts, 3 cuts. So for 10 equal parts, we have 9 deciles. For 100 equal parts, you'll have 99 percentiles. And remember, as we said, the first thing you do, arrange from the smallest to the largest. Let's look at an example to make sense of this. Remember, as we said, that this set of measurements are used for to identify the position of a data within the data set. So in order to do this, there must be a reference point. So your reference point is the x value, so which you have in this formula. So that's your x value. That's your x, and then you use that formula. So let's look at an example. So example 37, the shoe sizes in whole numbers for a sample of 12 male students in a statistics class were as follows. So if we are to look at these values, you see that is not in any order. So the question says, what is the percentile rank for a shoe size of 12? So the first thing we need to do, arrange the values from smallest to largest. So that's the first thing we do. So we've done that. So from 8 to 13. So the next thing we do is, remember, our point of reference is 12. That is our x. So the next thing we do is to calculate count the number of values before 12 or lower than 12. Remember the formula, the number of values lower than or below x. So let's count the number of values lower or below 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So going back to our formula, so it's 9 plus 0.5, 9 plus 0.5 times 100%. And this, remember, the value 12 here is not same as this. No, it's not the same. The value 12 here is your n, meaning the number of values or the number of observations in the data set. So if you are to count, we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is how we got that 12. So the answer is 79.17. So the implication is the value of 12 corresponds to approximately the 79th percentile. So that's that. So that's the position of value 12 in the data set. So that's the position of value 12 in that data set. Let's move on to the next measure in statistics, and that is measures of dispersion. So the first set of measurements we looked at measures location of a data within the data set. The second measures or identifies the position of a data within the data set. The current one measures dispersion of a data set. Dispersion of a data set. Another way to describe dispersion is variability. So you want to see if there is a discrepancy. Is the discrepancy within the data set, is it wide or low? So let's make sense of this. Wide or narrow? Let's make sense of this by looking at example 38. So suppose there are 2 battery producing factories. From each factory, 10 batteries are drawn. So remember, we talked about productivity. We also mentioned the issue of quality check. So 10 batteries, meaning they went through the same process. So 10 have been drawn from factory 1, and these are the lifetimes that have been measured. Factory 1, 10 values again in from factory 2. So if we are to calculate the average for both, you see the average for both is 10. But that doesn't say anything about the quality. It doesn't tell us anything about the quality. So that's why we need measures of dispersion. So if the first measure of dispersion is called range. And range is simply the difference between the largest value and the smallest value. So if we are to look at factory 1, the largest value is 10.1, the smallest value is 9.9. So the range would then be 10.1 minus 9.9, 0.2. And then do the same thing for factory 2. The smallest is 3. The smallest value is 3. The largest value is 16. So the range for that is 13. So what does this tell us? The variability here is low. So the variability in factory 1 is lower than in factory 2. The implication of that is the reliability of the product of the battery in factory 1 is higher because of the low variability. So there are other measures of variability or dispersion, which are standard deviation, variance, and coefficient of variation. So please take note of the different formula provided for this. So those are the different other forms to calculate your dispersion. So, but the general thing that you need to, or the main message, the main thing you need to take note of is whatever measure of dispersion you have. So when you're comparing different products, be it you use range, standard deviation, coefficient of variation or variance, the lower the value, the lower the value, the that means the lower the value, the more reliable the product you are considering. So those are there are other theoretical things that I've added there for you to take note of. Please read through, and if there is any question, please don't hesitate to ask me. Drop me an email, send me a message on WhatsApp. Thank you.